Welcome back. Rock forming show excellent basal cleavage. Okay, is typical for perfect basal cleavage. Physical property.
Do not forget to like, comment, share, and subscribe to my channel.
Welcome back. Rock forming minerals, physical and optical properties. So this is part 1. In the previous episode, we have discussed about feldspar. Okay, in this tutorial, part 5, it is one of the most common rock-forming mineral, which is called mica. We will discuss here in this tutorial. As we know, mica is the most and crucial, important rock-forming minerals. Okay, so knowing these minerals is very better for identification and determinations of a rock or namings of a rock. Mica is a type of mineral with a layered or sheet-like structure that is one of the phyllosilicate mineral groups or silicate phyllosilicate groups of mineral. These minerals are widely distributed through the Earth's crust and are essential to its geological makeup in both igneous and metamorphic rock. Its composition is aluminosilicate containing potassium, iron, and magnesium. The geochemistry or the chemical makeup of the mica group or mica silicate mineral is aluminosilicate, potassium, iron, and magnesium. These elements are the main compositions of mica. It breaks easily into what? Film or thin sheets. There are several different varieties of mica family of a mineral, each with unique property and molecular makeup. Okay? There are many mica groups of mineral, but we have seen the most common mica group. Okay, they're unique. They have each mica minerals have its own unique property and molecular makeups. Common features of the mica mineral groups. The first one is cleavage. Show excellent basal cleavage or one sheet, allowing them to be easily split into thin flexible sheets. This is diagnostic feature. Okay, the most key diagnostic feature for mica group mineral is one perfect cleavage, having what? A perfect cleavage. Okay, that cleavage is break along its weakness. The second and most important features of the mica minerals is luster. Mica, it have pearly to vitreous luster. The lusters of mica minerals have vitreous luster or glassy luster. The third important physical property of or common features of the mica mineral is transparency. Muscovite is more transparent compared to that of biotite. Okay, which is generally opaque or translucent. Okay, the mica minerals have translucent and opaque property. One of the common features is also occurrence. Mica mineral found in various rock types, including granite, schist, gneiss, and pegmatite. It is also present in sedimentary rock derived from what? The weathering of thus pre-existing thus primary rocks, that is igneous and metamorphic. Paragenesis, or its formation, or its origin. Paragenesis refers to the sequence of mineral formation in rock or mineral deposit. Paragenesis means way of formation, or the genetics, or the paragenesis means the origins of the minerals, or way of origins of the minerals. In the context of mica mineral, particularly muscovite and biotite, the paragenesis can provide insight into the geological condition under which this mineral formed. Here is a general overview. We have seen some of the paragenesis of the mica minerals. The first one and most important is granite and pegmatite formation. Muscovite and biotite commonly form in granitic and pegmatite rocks. These rocks are rich in silica and aluminium, providing favorable conditions for the crystallization of mica minerals. So, one of the paragenesis or way of formation or the genetics of the mica minerals are granite and pegmatite formation. Okay, the second paragenesis are muscovite formation. Second one is what? Muscovite formation. In the early stage of granite crystallization or crystallizations of magma, when the melt is still relatively enriched in aluminum and potassium, muscovite tend to what? Crystallize. Muscovite is often found in the outer zones of the granite. The third important paragenesis of the mica minerals are biotite formation. As the granite cools further, with decreasing aluminum and potassium availability, biotite starts to crystallize. Okay? Biotite is typically found in the inner zones of granite. So, pegmatites, which are coarse-grained igneous rock, can also host or contain both muscovite and the fourth and important paragenesis of mica minerals are metamorphic process. Both muscovite and biotite are common constituents of metamorphic rock, such as schist and gneiss. During metamorphism, existing minerals may recrystallize and new minerals may form due to a change in temperature and pressure. Yes, we have now. Muscovite is associated with lower grade metamorphism, while biotite is more common in high grade metamorphism. Okay? Muscovite in low grade metamorphism, whereas biotite is in high grade metamorphism. Their occurrence, okay? Fifth, the fifth paragenesis of mica minerals are hydrothermal alteration. Okay? Mica minerals can also form as a result of hydrothermal alteration. Hot fluid rich in elements like potassium and aluminum can alter existing mineral to form muscovite into what? Biotite. 6. Accessory minerals. Both muscovite and biotite can occur as accessory minerals in a variety of rock types. They may be present in a small quantity in sedimentary rocks, contributing to their overall mineral composition. Okay? Understanding the paragenesis of mica minerals is crucial for interpreting the geological history of the region. The present and distribution of muscovite and biotite can provide clue about the conditions during rock formation, the degree of metamorphism, and the mineral assemblage that exists at different stages in the geological evolutions of an area. Okay? The two most common types of mica minerals are muscovite and biotite, each with its distinctive physical characteristics. Okay, we have seen the most common minerals of the micas are biotite and muscovite. We have seen these two minerals, it is their physical and optical property. The first most important properties of mineral identifications are physical property. Okay, the first one is muscovite. Composition. Muscovite is a potassium-rich mica. Okay? Potassium, aluminum 2, aluminum Si3 or 10, with water. Okay? This is the chemical formula of the muscovite. The other important physical property of muscovite is it is color. Typically, muscovite is colorless or light color, often exhibit silvery shine due to its perfect cleavage in thin sheets. Okay, the color of the muscovite is colorless or light color. This is due to what? The perfect cleavage in thin sheet. Okay. Important physical property for muscovite is crystal system. So the crystal systems of muscovite is monoclinic. That muscovite has excellent basal cleavage, allowing it to be what? Easily split into thin sheet, biaxial sheet. It is transparent to translucent, as pearly to vitreous luster. Transparent to translucent, that's property, other property, okay? And it is also pearly to vitreous luster. The second and most important mineral in Mica group is biotite. Its composition is most of the time ferromagnesia. That's related to what? Like pyroxene and biotite, pyroxene and antimony. This mineral, that is biotite, is formed at high temperature relative to what? Muscovite. Their color is also black due to what? The iron magnesium rich relative to muscovite. Muscovite is mostly white, and it is that sheet or that transfer. It is perfect. Due to that, it is formed at the end of magma crystallization in the Bones reaction series. We have seen the physical property of biotite like that of the muscovite. Composition. We have seen the composition of biotite. Biotite is an iron and magnesium rich. Okay? What I have said. We have seen the color. The most important distinct feature for distinguish it from muscovite is color. Generally dark brown to what? Black. With this distinct dark brown to greenish brown streak. The color, generally the color of the biotite is black because of the iron and magnesium mineral present with other impurity. The crystal system is similar to that of muscovite, but their difference is chemical composition because there is variety of chemical composition during magma crystallization. So, crystal systems of biotite is similar to that of muscovite, that is monoclinic. Perfect basal cleavage. Okay, these are the diagnostic features of the two most mica minerals in the Mica group. We have seen other important. We have discussed in the previous section minerals and rock identification. There are three main important methods to determine rocks, minerals in the field or where in the laboratory. These are: the first one is physical property, the second one is optical property, and the third important and accurate, and it is a very expensive method of minerals and rock identification is geochemistry. So we have seen the physical property of biotite and muscovite, and the second most important is optical property. To now, a mineral, if we have confused mineral identification in physical property, we have make the thin sections of that sample and examine that thin section to microscope. To determine that mineral, first knowing the optical property of the mineral. If we don't know the optical property of a mineral, it is difficult to determine minerals in the microscope. Okay, which property have biotite and muscovite in microscope or optical property, or what are the diagnostic features for determining biotite and muscovite in the microscope? We will see practically in the future after we have finished theoretical part of this lecture. Okay, don't worry about the practical. The first one, optical property of biotite. The first one is refractive index of the biotite. Biotite has a relatively high refractive index, typically range between 1.55 up to 1.6. Sorry, this is calculated. That means it has high really relative to what? The surrounding minerals or grains. The second and important optical property that determines to determine biotite is birefringence. Biotite show moderate to high birefringence. Birefringence is the difference between the highest and lowest refractive index within the mineral. Okay. Color show pleochroism, meaning it shows different color when viewed from different angles. The color can range from brown, green to brown or yellow brown, depending on the orientation. Okay, the color of biotite in microscope most of the time it shows what? Brown color. Okay, brown color. Color seen in PPL. Plane polarized light. When the microscope adjusts in plane polarized, that means the analyzer is out. Okay, during that time, the mineral biotite show brown color. Okay, other optical properties of biotite is extinction. When the analyzer is in the microscope and rotates the stage of the microscope through 360 degree, the mineral grain biotite, in which angle it becomes black. That is the extinction. Biotite may show distinct extinction pattern under cross-polarized polarizer, providing additional information for identification. Biotite commonly show pleochroism, where it shows different color when viewed along different crystallographic axes. That means when the microscope adjusts in plane polarized light or PPL and rotates the stage, the mineral biotite show changing color. That's from color white to brown, white to brown. This is what we call as that pleochroism. So the diagnostic feature, the optical diagnostic feature for biotite is pleochroism. The other important optical properties of biotite is interference color. The interference color seen in biotite under dissection can help geologists to determine its thickness, okay, and provide information about the mineral composition and strains. Most important diagnostic feature to determine biotite in microscope is pleochroism, color, and cleavage. It has 1/6 of cleavage in microscope also. Its color is brown to white or most of the time brown, and it shows what? Pleochroism. That means brown to white, brown to white. This color change in plane polarized light is called as pleochroism. So the diagnostic feature the diagnostic features of biotite in microscope is these three properties. The second most important mineral is muscovite. Okay, the optical property of muscovite. The first one is refractive index. Okay, muscovite generally has a low refractive index compared to that of biotite. Typically range between 1.53 up to 1.56. The second optical property of muscovite is birefringence. Muscovite has low birefringence compared to biotite. The difference in refractive index is not as pronounced. Okay, color. Muscovite is usually colorless or light color, like that of the physical property. It may show slight yellow, green, or brown tint, but it's like the strong pleochroism seen in biotite. Okay, its color is colorless or light. Extinction. Muscovite may show extinction pattern under cross-polarizing its identification. Pleochroism. Muscovite is typically not pleochroic or show very weak pleochroism, or it can't show pleochroism. The other important optical property of muscovite is interference color. Muscovite show interference color under cross-polarizer, providing information about the mineral thickness and its crystal orientation. Diagnostic feature of muscovite, the difference between, or the diagnostic features, the diagnostic optical properties of muscovite is it has perfect cleavage and it can't show pleochroism and its color is colorless. Understanding the optical properties of mica mineral is crucial when studying thin sections of rock under petrographic microscope. It is very important. The combination of this property helps geologists differentiate between minerals like biotite and muscovite, contributing to the interpretation of rocks, geological history, and conditions of the formation.
Do not forget to like, comment, share, and subscribe to my channel.